Hello everyone. We are very happy to host this session now, the third day of our FabX Live conference with Marcin Jakubowski. It's called Extreme Enterprise, How to Create an Open Source Hardware Enterprise in a Weekend. Yes. And Marcin is from Open Source Ecology. He has a lot of experience with various projects and of the open source movement. And we hope that he will guide you through and you will be able to interact with him in this session. So hello, Marcin.
Thank you. Thank you for the intro. So ready to start? Okay, and you can hear me. Okay, well, welcome everybody. So my name is Marcin, founder of Open Source Ecology. I've been working on the Global Village construction set for the last decade already. If you're not familiar with the project, just a quick overview: open source blueprints for civilization. This is all the 50 different machines that it takes to make a modern life with modern comforts, everything from a tractor to an oven to a circuit maker. It's a fully open source platform. But more than a technological development, I would really call it a humanitarian or social development, because in order to get the collaborative development, you need to learn to collaborate. So that's the big thing, because there's a lot of limits to what collaboration does today. The world is highly proprietary. In my own PhD program, as I studied, I could not talk openly about my work, for example, because we had some hot material in our work. I studied fusion energy, and I thought, wow, this is pretty wasteful. What would it look like if we truly collaborated with one another to solve bigger problems, to make a better world for everybody? And given that the scientific field I was getting into didn't do it for me, I decided to start the Open Source Ecology project, and I've been working on that since I graduated in 2004, so that's been over a decade. I got landed in Missouri factory farm in 2006. 2011, okay, so if you haven't heard about this work yet, do take a look at my 4-minute TED Talk on the Global Village construction set. That's the best overview in 4 minutes. So what I'll do today is talk about our progress to date. So what have we learned over all this time of prototyping? Because we've done a bunch of work, lots of proofs of concepts and real builds, many of them. So what do we do? Results to date, all the proofs of concept that we have done to date on rapid crowd-based open hardware development and builds. This is not just development, it's real builds with a lot of people swarming on collaborative build projects. So what are the opportunities and limits there? And then I'm going to discuss the missing link, which we have not gotten to yet, and that is the enterprise aspect, the concept of extreme enterprise, the one missing link. The idea here is that in some way, open hardware has not succeeded, well, like software, clearly. Open source software, Linux is the backbone of the internet. The same thing's going to happen with hardware, but it hasn't happened yet. Why not? We've been at this game for a long time, and we're really trying to understand the question, like, what does it really take? And our latest conclusion on this is we got to get to the product level, develop products that change people's lives right now. So here's our latest plan of how to do it. So first, I'll start with what we have done to date. So we've prototyped a bunch of machines since 2008. So this kind of represents a bunch of stuff until 2013, which then I lost track, but hundreds of machines around the world. With these milestones. So first of all, we found out, okay, we published the plans of our compressed earth block press, and we found that people can just download our plans and replicate. So this is actually the first ever replication in 2008 of a 2,000-pound brick press that produces bricks from raw soil. We found that by documenting our work and including pretty good documentation like IKEA-style fabrication diagrams, people could replicate this stuff. Great, awesome. But we design with radical modularity in mind. So we've actually proven out some very efficient ways that modularity can get you to very rapid builds by the concept of reusing parts like Legos. So if you have access to building your own frames, power units, or universal rotors like this life-size thing, you can build a life-size tractor like this. And the modularity is captured, you see here in the picture, the drive for this trencher unit is the same unit that's on the wheels of the tractor. It's the same module. So radical modularity gets you to build things fast. Or this is a smaller micro tractor, which is a power cube, the power unit, and a tracked version, much smaller, a walk-behind tractor. But the way you can do this, you can break down, just like Linux has succeeded in software by breaking down the whole complex kernel into many, many parts. We can do the same with hardware. And that's exactly what we do. We break each machine down into modules. So this is the modularity concept. And then we can develop each module according to many steps, like 20 development steps or so. So this modularity concept really applies that you can take a lot of people working at the same time, not to just only to design, but also to build. But further, you can get into the idea of a construction set approach. If you have these modules, well, then you can produce a tractor, a bulldozer, a backhoe, or whatever, or a car with similar modules. But that kind of method applies not only to mechanical things, but other things like electronics, like fabrication equipment. So we turn everything into a construction set. So instead of building one thing in a design effort, you can build 100 things because they have the similar modules. So what does modularity allow you to do? We found that one amazing result is the radical reduction of prototyping time from months to days. So I show this example. This is an ironworker machine. It's a metal cutting machine. You can cut 1 by 12-inch slabs of steel with it. The blue machine here took us 6 months. We redesigned it for modularity, and the machine in the corner on the right-hand side still cuts 1 by 10-inch steel. We built that in 2 days with 2 people. Radical difference. Moving on. Using these methods of modularity and breaking down machines into modules, we can build things very rapidly. So for example, the brick press, we achieved the first ever build in 2011, 2012, I think, of the full-scale CEB machine in 1 day with 12 people. So each team worked on a module, and then we assembled it rapidly into place. So this 1 day rapid manufacturing of real life-size stuff is real. And okay, so next milestone, scalability. So here we show actually our small printers. We actually make and sell these. But the point here is that we design our stuff to scale. So here you see a 8mm rod universal axis for 3D printers. You can make a larger printer with it. Or you can make, that's the original 8mm version with a 25mm version. Same idea, larger size. So you can build a larger machine like a CNC torch table. Or you can even increase that to 50mm moving parts, 2-inch heavy shafts to make a heavy duty milling machine like this. This is not finished. But to give you the idea of scalability, yes, you can do it. Design it so you can scale things in a radical way. So I don't know if we should take questions at any time, but I mean, maybe we can wait till the end because I got kind of a lot of stuff to cover. So maybe take notes if you'd like, and then ask me everything at the end. We'll have plenty of time, like 20 minutes probably to go over questions. So the next thing we found out that you can also do real-time documentation. We've had, like, for example, during the build of the ironworker machine, the machine that cuts steel, we had a remote team through Google Hangouts. We were taking pictures and uploading it in real time, and we had an instructional done at the same time as the build. That's very powerful because a lot of times you lose the ability to, you just don't document because it takes twice the effort. Needless to say, all the hardware, open hardware work, it's a lot of work from building to documenting and everything. And then we're going to get into the enterprise, which is the even next level. So we also learned about swarm builds. This is not us. That's the Amish building a big barn in a day or a couple of days. We do this. We build this seed eco home. This is actually where I live. This is my house where I'm presenting from right now. We build that in 5 days with 50 people. Once again, modular design. You might not see that here, but this is panelized design. Most of the parts here in this house are 4x8 modules that you build in a workshop and then assemble rapidly into place. So once again, the swarm build concept, that's what we do. You can see that for lower, smaller structures, like some of the older compressed earth block structures. It requires very careful planning of the workflow. We've done a lot of work on that, how to do that. So in our last build, this is actually a build of a micro house in Belize. Wow, that was actually a good milestone because here we showed how, with very careful planning, we had all the bricks lined up on pallets. We had a big thing of slurry mortar mixed in a drum by a tractor, and we could lay these bricks like laying them against the back stops a few seconds per block. So we got to this extremely rapid way to do this. So if you actually kept that rate up, and of course we didn't because, you know, we're still figuring things out. Well, you could build a house like this, like the entire walls in like an hour or two. If you have enough people, you can have a bunch of people on each side. But this is real. You can do very rapid building. So that's the Belize house with our team. That was a 5-day build just this February. Um, well, next thing. So next milestone, we learned about product ecologies. So the way we design the whole Global Village construction set is for machines that make machines. It's a familiar concept with Fab Academy, the Fab Labs. So you start with a printer, you make parts for larger machines like the torch table, and then the torch table can cut steel to make larger machines like tractors and brick presses. So that's a basic product ecology of machines making machines, but also, I mean, machines for ecological uses, like we build these aquaponic greenhouses. You can use the 3D printer to print the towers. You have the panelized construction, like you see the ceiling and the walls here are panels. That's the modular design. You can use the backhoe to dig the trenches, the ponds here and so forth. So you can build at lower cost and affordably. And this is one of the products we're trying to get out to the market to actually make this a replicable way to build this. But let's talk also about lifetime design. If you have open blueprints, radically open blueprints, you can see how everything is done. So you can talk about lifetime design because you know how to fix it for a whole life. And you can talk about the circular economy. So here we're showing some of the other machines of the Global Village construction set. Like right here, we've got the shredder. So you can shred your cars, tractors, and plastic, and you can melt the metal or melt the plastic and extrude it into 3D printing filament or virgin steel to then make more machines in a circular way. So actually the whole Global Village construction set consists of the tools that are able to take you from scrap materials like, say, scrap steel to virgin steel, and then to a modern economy with precision machining and so forth. So that's all about the circular economy. Let's make that happen on a smaller scale in our communities. So next thing, all this boils down to, we've discovered that industrial productivity can be achieved on a small scale. You may have heard me say that in a TED Talk. And that's absolutely right. I talk about building a tractor in 6 days in the TED Talk. We've done much better. We've built a tractor in 1 day. For example, to plant out, you see the fields back there. We planted out a bunch of hazelnuts. We built a purpose-built tractor just to plant that out in 1 day with like 4 people. And then we actually took the tractor apart to make other tractors and other machines. So industrial productivity is feasible on a small scale. And there are no limits to that, really. If you look at it, what can we do? The same dirt that you see here making block, that's aluminosilicate, that can be used to make aluminum. So aluminosilicate, aluminum is one of the most abundant elements in the Earth's crust. If you have a machine to extract aluminum from clay, you can make your own metals from the dirt and twigs beneath your feet. So we're talking about abundant resources, abundant energy as in there's 10,000 times more power that comes from the sun than we use today. So there's plenty of energy, plenty of materials. We're saying, how do we make a better world for everyone by doing that? And talking about high tech on a small scale, you can even do this. You can see this video that's Dan Gelbart. Some of you might have seen this guy. You can make this precision air bearing lathe in your workshop. You can get all the parts for this. This is a super precise lathe that allows you to make air bearings, which are used in high speed, say, vacuum pumps that get you to clean room technology and making engines and rocket ships and all that. So we have the access to this amazing technology on a small scale, and we're working with that. But the final frontier, like, okay, why don't we have prosperity for everyone? So I'll talk about here now the big limit of open hardware that we've seen so far is getting people to show up. You know, we've done some things, but all the time it's been a struggle to get people to show up. So how do you get people to show up? Because it takes a tremendous amount of effort to take something from a design to a product and a marketable product. Like here, this is the house I live in here. That's the Sidika home. We're trying to turn that into a product that you can get at a low cost. But I'm going to mention the concept of what I've identified as I call it the open source hardware trap. That is that open source hardware is not efficient at making products. So take a look at, and I think the CNC router is the prototypical example. Count the number of CNC router projects that have been out there, that have thousands of them, that never actually end up making a real product. It's still hard to find a decent CNC router that you can make as an open source product. But the idea is you get to a certain place of development, and then you find out that, wow, it takes not only like a couple of prototypes or 3 prototypes, but like a dozen or 100 prototypes to get something to completion. It's a lot of work. If you make the analogy to software, how many bug fixes do people make when they release a piece of code? Thousands. Well, similar analogy applies to hardware. You have to do a lot of prototyping, like a dozen, so you got a product. So the open source hardware trap is the fact that the typical user or developer will do something and make a half-assed product and then kind of give up. It's too hard, too many tries to get it to completion. And then the next person comes along, starts reinventing the wheel because typically the documentation is not really good and the people don't care about documenting, and they end up reinventing the wheel, getting to a certain product, and it quits, never finishing. So thousands of prototypes are made. None of them come to completion. And eventually the proprietary corporate guy says, oh, I'm just going to put in $1 million to finish a product and sell it. Well, it probably takes many millions of so-called wasted open source effort where people don't end up with products. But I call that the open hardware trap. We don't have the good tools and techniques to take products to an efficient development process in hardware. Even though like the 3D printers, open source 3D printers, they have dominated the landscape, like Prusa printers. Well, but that's still, people kind of haven't noticed that. And certainly the open development is not the norm. Okay, so here we talk about, let's talk about solutions to that. Let's talk about distributive enterprise. So what if we now focus on taking what we have, and so this is the concept, myself and Colby have written about it in the Innovations Journal. This is about making enterprise, that you're designing the enterprise to be replicated and you're teaching others freely to do that. That's called free enterprise. The idea that you're trying to level the playing field by opening up all your blueprints, and not only on the technology side, but on the enterprise side. Let's do it. Because if you think about it, if we got all the effort together of the open source developers, you could, with enough eyeballs, you can make a product, you know, that fix all the bugs are shallow, right? So clearly you can make better products if everyone collaborated, but yet we compete and we're in a proprietary economy run by patents. So, but I mean, software has shown otherwise, right? So why aren't we doing this for hardware? So here's some of the milestones we have reached so far. We can, for example, build machines like the brick press. We can charge people for a workshop experience, immersion, welding, training, kind of a workshop experience. We can sell the machine. So we've done this. Like we can turn like $10,000 over a weekend, 5,000 from selling the machine, and say 5,000 from tuition from people. We've done that a couple of times. It's not a replicable model yet. It takes a lot of work to prepare it, but this is a point of enterprise development. This could be done. Like I could definitely see a possibility where you come into a workshop setting, you build a product, you can take it home with you, and that's a viable economic model. We're working on that. We've done that for 3D printers, like 12 people that build a 3D printer in a day. So there's a revenue model there. You can charge over the bill of materials cost and make a sustainable business out of that. Or with the house builds, our goal, I mean, we've run a workshop where the amount of people that showed up, I mean, people paid us to do this. So we got 25K in revenue from the workshop, which paid for half the materials of this. But can we take this further to make a viable economic model to build houses like that? And that's the next question. How do you take that house, which still isn't fully documented? Actually, you know, we did a Kickstarter on the Seed Eco Home in 2016. We couldn't really get the documentation out. We kind of failed on that part, but we're actually taking it again and based on the learnings. But we need the people to show up. Okay, so let's talk extreme enterprise. So what is this idea? So we're going to take on a project where we take our Seed Eco Home and attempt to turn it into a product in a rapid development event. Sorry, there's a noise here. Let me fix it. Okay, sorry about that. So the core of the extreme enterprise concept. We know that in all our open hardware work, it's really, really hard to get to the finished product level. So here's our plan. Okay, let's take a look at Linux first. Linux actually started with a guideline that when Linux started, Linus started by saying he has to make it work fast, simple thing that can be used to run most software. And Linus has achieved that. This is the history. In 1991, when Linux first originated by Linus Torvalds. And in 1 year, he had a program, a Unix equivalent that could run most Unix software. Okay, 1 year. So that's a comparison for baseline. So what have we been able to do so far? Well, Linux currently actually enjoys about 2,000 full-time developers. Well, it used to be that all the developers were volunteers initially, but now all the developers on Linux are pretty much getting paid by Microsoft, Facebook, and all that. That's a big success story. All the big companies understand that open source is effective. So there's about 2,000 people today that are developing Linux full time, getting paid. Now the key there is enterprise, the money that gets to pay these people. What do we do for hardware with that? Well, so I'll point you to a data point on our side. This is design sprints from open source Ecology 2013. I pulled this off the open source Ecology wiki. Well, look at our numbers. We had in our design sprints, which are remote development events, 20 people at most, 5 minimum. I mean, well, it's hard to get people to show up. You guys probably know that. So this is actually the state of completion after a decade of development. So these are all the machines. There's a few that are at the 100% level. Like right now, you can take the 3D printer, the actual CD home. That's I mean, it's, the documentation is there. It's all the blueprints are actually there. It needs better documentation. The brick press, the power cube, micro tractor, those things are pretty much ready for prime time in terms of starting enterprise. So from 2014 to 2018, we've increased a little bit. But no, this is not like Linux, where in 1 year they had a product. Here, our product is the new operating system for civilization. Like, how do we collaborate on product development? So it's a bigger problem. And we must say that hardware is not like 10 times harder or even 100 times harder. I think hardware is actually 1,000 times harder. It gets into physical realities, not pushing electrons around. So what do we do for getting products to the finish line with open hardware? Well, let's start by the open source breakdown on the design front for the product. So I showed this. We break machines down into modules, and then we develop on them. And then let's develop the enterprise side at the same time. So that needs more people. But you can break down an enterprise just like enterprise development could be the equivalent of a product development process. So let's start by defining what that looks like. So you have to develop the product, the production, the marketing, sales and support, improvement. So starting with unique value proposition, product strategy, business plan, production, quality control, marketing, web page, product assets, shipping, customer feedback, support, future work. I mean, you can break this down and start developing this. So our idea is, what if we pull together 2,000 people over 1 weekend to do this? Okay. So we have to start with a big, hairy, audacious goal. A house is of high interest. So now we're saying, okay, based on our experience with a CD home and all the other builds we have, we believe we can produce 1,000 square foot home that you can build with a friend in 1 week for $50,000. Okay, that's competitive. The average house cost in America is much higher. Our goal here is to do at least 1/3 the cost of industry standards. There is a catch, I'll talk about this, but this is our milestone. Can we attract people for that? I think so. So we create a weekend events, kind of like a startup camp or a hackathon, but souped up and taken to the next extreme. So if you have 2,000 people show up, 24 hours on that weekend, that's 24,000 hours, equivalent of 12 human years in 1 weekend. So the challenge is, how can you coordinate that? It's a hard challenge. Now, what we envision is taking this CDCA home and the modular construction method for building houses. So you can look up actually Open Building Institute, Google that. It's in the links in the presentation. You can actually see it in the presentation notes. But the idea is create the Bible, the big publication, probably about 2,000 pages that walks you through the complete build and enterprise of how you build these houses. 2,000 pages might be a little short, but that's about a page per person on average. So like if you pack all this effort into this short time, that's a possibility. So how do you turn this impossible project into possible? Well, first, everyone who participates in this extreme event gets a chance to buy this house for $50,000. We're solving for why people are not showing up, and that is the product. So can we actually get to that product in this crazy weekend? Let's move on. So I'm at, I have about 10 more minutes. So let's talk about what this would take. So what we see right now, and this is a new idea, it's been around for a month, but we're very excited about this and moving forward. About 4 months of preparation time to line up the concept and launch the project. Then for about the next 6 months, we will recruit people. So basically we're saying we've got this development architecture, role architecture of what all the things that need to be done lined up. And you can take that through an agile development process and come out with a product on the other side. So it once again relies on this radical breakdown of tasks to every single task that's required to do this. We can break the house down into modules. Now, fortunately, a house is not too bad. We've built a few, but you only need 4 things. You got a foundation, you got a floor, you got walls, and you got a roof. Okay, 4 modules right there. Well, there's more. There's the PV system, there's the water system, there's the toilet, there's the kitchen, there's the heat, utility connection, some other things. But you can start with a modular breakdown and then deploy teams on each one of them at the product level and the enterprise level. So far, I'm not really hearing anybody but us talk about the distributive enterprise concept. And this is a call out to anybody, talk to us. We're looking for people who believe in developing a business model that's then shared openly and believing that collaboratively we can do better. The idea that the business solves for a bigger problem. And what problem are we solving for here? This is affordable housing. This is about land speculation. Like, how do you take this house if we build it at low cost? What takes people from then speculating on that in the market and then having the same problem of housing being unaffordable? Well, let's tackle this problem together. Together, we can come up with a solution. So we develop both on the technology side and an innovative business model that can deploy this all over the world, starting with America here. But anyway, for the organizational part, what we see is to onboard, like you're gonna have to get everybody on board to a common development platform. And that is, it's not too bad. We know that wikis work like Wikipedia. We have FreeCAD open source 3D design software. We have live editable docs such as Google Docs or Etherpad, but with a very basic infrastructure and templates on the wiki and other tools of modular breakdown which exist. I'm not going to go into that. We're confident that kind of process can exist. So can we get the people to show up? Yes. Can we onboard them? Well, I think it would take 4 full-time people for about 6 months to spend about 2 hours each with each person to understand exactly what we're doing and where to put the documentation once we develop. And so say one person develops a Blender animation to show how the house goes together, an instructional, or the design for the updated photovoltaic system bill of materials and stuff like that. There's 1,000 roles, right? You can line those roles up and have people execute, and each person has to produce like 1 or 2 pages of assets that are then put together into a publication that's another product available for free. But you can break this down radically into a thing that's actually a tractable project. So 2 hours, we select people very deliberately for all the skill sets. We're not going to be just like open call, anybody show up, it's a wild house. No, we're going to need to be very careful. We're going to architect the collaboration architecture very carefully so we have all the roles showing up to develop the things that we need. I kind of call it the agile waterfall because it's kind of top-down scripted like waterfall development, but it's agile in that it's completely editable by everybody. It's completely collaborative. Like if we learn new things during the process, we switch course. We have an initial outline, but we're all after a common product, a affordable home that's modular, that you can build as modules of 250 square foot modules for a 1,000 square foot house. That's 4 modules like that. Okay. But yeah, it requires that everyone gets on board primarily to the collaborative literacy aspect. How do people know what to develop, where to put it once they develop it? How do you manage conflicts of people submitting things? All those tools exist. Wikis, version control, standard techniques. I'm not going to go into that right now. But let's talk about, okay, so let's talk about this 50K house product. Is that for real? Well, here's the catch. So what we envision is that we develop a product that can be dropped shipped as a kit that you can build in a week with a friend. But here's the catch. There is a little bit of catch to do this in a week. It's a modular house. So what happens is you can build a few panels and stash them like over every weekend. So like this house here is made up of 4x8 panels primarily. So you have to do that for about 32 weeks. So actually the numbers for a 1,000 square foot house, you'd have to do 32 weeks, 8-hour weekend, if you're working by yourself. If you get 4 friends, then you're spending 2 hours every weekend. And after 32 weeks, you've got all the panels for the house. Bam. Here's the other catch. BYOL, bring your own land. Sorry, land price is not included. But in America, at least, I can talk Google's Zillow.com right now. You've got parcels from $3,000 to $20,000 everywhere. It may be in the most undesirable place in the country, in the US. It could be the ghetto. It could be in the middle of a desert. But that's all the definition of what's desirable. A desirable thing for one person may be not desirable for another, and completely undesirable package might be completely desirable for somebody else. Like, for example, if you're a telecommuter, it doesn't matter if you get a $3,000 or $10,000 plot of land somewhere, as long as you have internet and a UPS truck. So trust me, there's a look at, I mean, you'd be amazed. I just Googled Zillow the other day, Zillow.com, plenty of parcels in big cities, Chicago, Trenton, New Jersey, San Diego, 2 hours from San Diego, a plot of land for $8,000. You Google it, there's a lot of land. And I can't say about other countries, except like maybe in Spain, you can get a whole village for $100,000. I don't know. But yeah, there's going to be opportunities to get land. We have to address that too. So the next step is we still need a house. All right. Well, we're going to need to develop that. We have good prototypes that we're confident we can build. To me personally, I think the business side of developing this is hard. I think the house technology is quite tractable based on the ergonomics that we have seen of building structures like this. So let's talk about baselines of structure. If you go through the numbers, you can check my math here, but each module for 250 square feet costs $6,000. So that's $24,000 in materials. That includes a helical pier foundation, which is a good way to go. So the bottom line is, as I mentioned, 32 8-hour weekends with one person that you build all these modules at $6,000 per 256 square foot house unit that's made of 32 modules. Take a look at this. Now, that's $24,000. We still need more things, like probably $5,000 in PV system, a few more ticket items like bathroom, kitchen, appliances and stuff, which add up to another $10,000 or $15,000. But I think the budget looks pretty good that altogether we need to make this model work out for around $50,000. So the process we go through here is we talk about OSC specifications, modularity, scalability, eco, all these features of being easy to build, designed for a lifetime, and made human-centric, appropriate technology. So we then create the requirements for all the modules. We create a few products. So out of this comes the house product. It might be some modeling kits. It might be a book. It might be training for entrepreneurs. It might be training for consultants and training for OSE chapters. We'd like to actually use this as a way to deploy open source ecology chapters throughout the world that can actually produce these houses. So after you got a product strategy, you do role architecture for each product, and then you develop all the enterprise modules and the technology modules. So this is kind of like the big picture overview here. So basically, if you have a module, as long as you know how it fits with other modules, then you're good to go. That's called module-based design. That's called interface design. You design both the interface and the module, so you know how things fit together. So therefore, if another person is working on another module, they know how it all fits together. Okay, so I've got like about 5 minutes left here, and I'll stop talking and take questions. But okay, so I'm going to go a little bit into the enterprise role architecture. So here, the product design, that's pretty standard. Product development methodology, or you can actually Google open source product design or some other seminal work on product design, and there's a bunch of steps you have to take. So that's the product design team. That's the 20 or 40 steps you take to develop each product from a concept to a built and tested product. The green here is the technology side. All this other stuff is I'm starting to talk about enterprise. Okay, what's the product? What's the tooling? What's the certification for builders? Business plans, supply chain, publishing, technical documentation, brand, open source franchise, marketing strategy, admissible vendors list, more stuff, inventory control, quality control, facility design, workshop model, shipping, packaging, continuing improvement, blah, blah, blah. You've got a lot of different things on the enterprise side, and you can continue, you can keep breaking this down to various roles that we have to get pretty granular about and fit people into these roles. So you've got, on the technology front, you've got a lot of different assets. I mean, it's technical design and documentation primarily. There's CAD involved, there's graphics, there's animation, there's technical writing, there's construction skills, that people who know how to design construction things, so architects and others. So there's a lot of work to be done. Now, how does this work for, how do we deliver this? So say we show up for this 2,000 person event over a weekend. This is remote, by the way, because it's COVID time. So it's actually a good opportunity. And we're looking at a schedule of this 1 year from now, 10 months to a year from now for deploying this challenge. So the event produces the know-how, right? That's information. And then there's training. So we're being deliberate about the products here being, there's information, there's education, and then there's actual product proper, the hardware, the house. But there's products around education that can be created, and products around information, not really around information. Information is typically free. But education, if it takes your time to train people, you can charge for that. So we developed the information and training materials during the 2,000 person weekend event. Out of that, there's going to be a longer immersion program for entrepreneurs. So in that 2,000 people, we'd like to have 100 to 200 entrepreneurs that are going to actually deliver these houses to your doorstep through a drop ship of all the parts that you could get to build in 32 weekends, either in 2 or 8 hours, depending if you have any friends or if you're doing it yourself even. But it's actually doable by yourself if you can spend 8 hours every weekend and then get a person to help you on a week of build out. So the way we do this is we're planning on, so all the entrepreneurs in the development event, we give them leads to give them 5 or 10 of the houses to deliver. They can get paid for that, right? There's revenue, there's a business model involved in this. Some of the entrepreneurs, we'd like to have them start OSE chapters and get certified according to OSE specifications, meaning all the values that open source ecology harbors, to be part of the open source ecology movement as we expand and now have staff and all that. Because right now it's all been volunteers and not having a team. That's been a persistent issue with volunteers. But once you train entrepreneurs, you have to address defection as well. People who are going to leave your team, right? Because they can, once you have this amazing information, you can just make probably more money, not making affordable housing, but making expensive housing, because probably market will bear that. That's an issue that has to be addressed. And I think the way to do that is to make sure that we train enough people and continue the development of the product that there's enough supply of affordable housing that you actually have a person out in the market looking for a house has a viable choice between an affordable house that we can provide or a speculative house much more expensive. So that's a big question here, because we're going for a big problem, and that is affordable housing. So we're going to need all the help we can get. It's a problem that I cannot solve myself. You may not be able to solve yourself. If we invite 2,000 people as a start, and then the whole world to boot, because we're ethical and transparent, and this is a model to provide real service to humanity, then we can do it. So there's no free lunch here. This is going to be some serious work, some serious innovation. What else? So the execution is, we're looking at 2,000 houses. Wow, that's pretty huge. So there's a 3-day Extreme Enterprise event. 1 year from that, probably a few months after that, the entrepreneurs, they're going to have in the crew, the 200 entrepreneurs are going to have more training. You have to know about how to build a house exactly, how to source the parts. You have to have a much deeper understanding. That's more immersion housing. But within the first year, after the Extreme Enterprise event, we'd like to deploy, build the 1,000 houses with 200 people. So that's about 5 or 10 houses per entrepreneur. That's kind of how we're looking at it. And then after we train more people, deliver the next 1,000 houses over the second year. So that's kind of rough. I mean, these are ideas that we haven't really vetted yet, but that's roughly the schedule here. So participant track, 1,800 participants, 200 entrepreneurs, key to execution, and then chapters training. So this is 50,000 for a house that you build with a friend in 1 week. Bring your own land, financial model. We want to get the price down to 50K. I think it's doable, and we have to develop an enterprise model around that. So the challenges in this, it's not going to be easy to coordinate 2,000 people, onboard them, primarily onboard them. Once we show up for those 3 days, do we have enough information and awareness and placeholders and templates to do everything? Then, of course, you've got the enterprise detail, which, as I mentioned, I think is the harder part. I think the technology of the house itself is the easier part. And the question of speculation afterwards, like if we develop this open source affordable house, will people actually use that to speculate with and just sell it at high cost? We're gonna have to resolve that. Here's a link to the role architecture. Well, so next steps for us right here are detailed house budget. You saw a rough figure of 6,000. We're gonna get that to the dollar in a week or two. Detailed house budget, detailed enterprise model, blank page to be developed. So that's about all I have. You can find out more about, if you want to be, okay, so you guys are listening to, you're probably interested in this and helping out or participating in this. So definitely, you can sign up for our newsletter, opensourceecology.org. You can email me for more info, marcin@opensourceecology.org. Otherwise, I'd like to take questions and feedback on this. Crazy idea.
Yeah, hi Marcin. There have been a lot of questions now.
Yeah.
I request everyone, whosoever wants to come on the video can actually enable the video option and ask the question directly. Is there anyone who wants to start, or should I start taking the questions from start?
Yeah, who wants to start? Questions.
Okay, so okay, so I go one by one. Here, Pete is asking, do you have specification for the interfaces that you initially showed?
There's details. No, the short answer is no, but yes, you can derive those. No, I'll keep it at a no, because we've done an interface design and we found enough about it that we're gonna have to, we know we have to modify it. So at present, no, but you can definitely look at what we have before.
So you have that in your documentation?
Yeah, we do. The best place to look at is the Seed Eco Home page on the wiki. So okay. I can provide all those links for people, but if you look at my presentation, there should be a link there. Seed Eco Home Index.
Okay, then Philip is asking, scaling up seems possible, but what about scaling down? He comments that at a point in time, it will require really specialized and expensive plants, example CPU, LCD, fiber optics. Sometimes there is just one or two suppliers on the entire planet. So what do you think about that?
I see. So is this for the, at the level of the house or in general?
It looks like in general. Philip, if you are there, you can ask a question directly.
Okay, the answer to that is, sorry, okay, here we go. The answer is that we're scaling for both up and down. So we're designing for literally the desktop, starting with a desktop microfactory up to a 4,000 square foot workshop. But we operate really at the village level, which says, okay, essentially a 4,000 square foot microfactory can produce most things that a village scale would need, and many villages are a city. But if you scale down, yeah, there's tiny things that you can build, like with 3D printers, a torch table, or just a manual torch and basic equipment. There's a lot of stuff you can build. The key is really the access to the open source machines that can get you to that productivity. If you talk about scarce suppliers, well, That needs to be developed too. Like currently we're working on making plastic fully recyclable so you can make your 3D printing filament, something you can do on your desktop scale. But for more advanced things, there's going to be possibly bigger machines. But if you examine any process that's out there in the industrial world, like let's look at the air bearing lathe. That is like the best example where with that you can start manufacturing clean room equipment. You've got, you build structures with a brick press and construction equipment. You populate it with clean room equipment to make microchips. So you can go both up and down in scale. And the thing about technology is the concept of miniaturization. Right now with digital fabrication, you can do things at an unprecedented small scale. So you can be the next John Deere tractor manufacturing right in your workshop with a CNC torch table and a welder. That's literally true. So you can go both up and down in scale.
Then Clemens asks, how did you secure the financing for this massive project? By the way, absolutely awesome work.
Yeah, thank you. Are we talking about the house or now just all throughout? I mean, all throughout, we have been bootstrap funded. We've only had a budget of about $1.4 million to date over the decade from foundations. And right now it's true fans, crowdfunding, like we did some Kickstarters, but right now it's programmatic revenue, running workshops and selling our 3D printers and now rolling out other products. So we're bootstrap funded so that anybody can replicate it with no capital. Now, as far as the house project, how do we fund that? The people that participate. Isn't that interesting? Instead of asking people begging people to come, we're going to charge them. Will that work? I think so. Well, the funding model is quite innovative there. It's kind of turning the thing upside down, reversing the thing. But we're saying we're going to create an event of value that produces value, and you're going to want to be there. So it's actually designed, we're aiming for a self-funding model to demonstrate that crowd-funded development with a vision can succeed over any finance capital method. That's what we're solving for. We're saying, hey, we are going to solve for an efficient, open process that brings in the funding and has to compete. Like if, say we're making cordless drills, we'd have to have that kind of a power to develop something on a short time scale, and that's good enough to make it happen. That's what I see as the critical missing link why open source hardware is not really taking off. But let's actually talk about Prusa printers, let's say, as an example. They have taken off. They're like a $50 million business, I think. But their enterprise is not distributive. They're not teaching people how to build 3D printers and do more things. It's still a centralized business. And it took a long time to develop, maybe a few years. So it takes a long time. There's not really good precedence of the distributive enterprise model where you can take a model that many other people can replicate. And that's actually my ask to anyone out there. People like FarmBot, Prusa printers, Arduinos, or anybody who's got a product, let's come together and let's share the businesses so each of the businesses become better. And you have the next Amazon as a result. Open source microfactories fueled by open source plans.
Okay. Clemens asks, is there any effort planned to be compatible with European housing rules as a wooden house, as this appears, does not fulfill the energy standard required for every new house built? Basically, the question is around the regulations depending on the different countries.
Yes.
So what is your take on that?
The answer is modular breakdown. So we can have a modular design for the USA. We can have, if we have more participation, or maybe like, so this event will be US centric. Because for example, I don't know anything about the supply chain in Germany, right? Whereas I know some about the US. So we're going to do that for the US first to manage risk and develop that as a feasible thing. But then again, so if this method succeeds, we can do this event again for Europe, or as part of this event, if we have enough Europeans participating, they can do the codes for the European version. that could be a module. Here's the module for America, the basic module for America. Here's the basic module for other places. And it can be modularized down to each country, and it will have to be modularized down and localized to each country for it to be feasible.
Okay. I request Ayodhil Arik Babu. I'm really sorry if I'm not pronouncing your name correctly. So please come on video and ask to share your comments and ask your questions. Ayodhil.
Yeah. Hi, Martin.
Hi, Ayo.
My question was about the localization of the idea. For example, $50,000 is about 3 times what it would cost to do what would be considered affordable housing in Nigeria. So I was asking that, okay, how can we like benchmark the cost? I'm sure it's possible to still do it within that range, but how do we verify that and know that that we're essentially how can that be done in Nigeria? I also made a suggestion that if you're looking at making the seed eco house into a product, why not go all the way and look at a small village? Why not go look at creating go all the way, get this land that it says available for cheap in America, and do a mini village of 50 or 100 units.
No, that's
so you can build in all the open source ethos into the same space and get like-minded people who want to own property with like-minded people to, sort of kickstart this civilization, like we're saying.
Absolutely.
Those are two things.
Okay, good questions. So yes, the question we were just talking about that today about larger scale developments. Well, we want to get really good at making sure we can do one unit, because once you have that, you can readily now say we've now built a few of these houses, then you can go for an entire village. That is much more complex as a project. So I think the very, very easy place to start. There's land, that's probably not in a city, it may be like outskirts of a city or close to rural. Someone's got land and they want to do it. Get a few of those done. You can readily go to that village, and that's certainly the next step. But I wouldn't start with that, because just for the permitting of that, if you're going to do that, even if you're in the middle of nowhere, I mean, I'm not sure how that would work, but it's much harder than just a unit or a few units, but definitely in a plan. Now, we're also designing to address that for village scale. Each house is, first of all, scalable. It's a seed home. You build one seed, and then you can add on to it in 256 square foot modules. And we're actually considering flat roofs you can stack on top too. Okay, you can do that. That actually addresses your question, like, would you be happy with a smaller house in Nigeria with the US supply chains at that cost? Well, you can either go to a smaller house unit, or you have to work with your local supply chains. Maybe there's stuff that's much better there that you have access to. Maybe, well, first of all, you're in a tropical country, let's say, you probably don't need all the insulation or freeze proofing that we need. So there's probably ways, like for the tropical areas, you can go way cheaper. Like in a Belize build, we'd not have to worry anything about pipes freezing or insulation. So I think there's ways to go about it, but then you definitely have to have involvement of people like yourself to say, okay, here's what the model. Once again, in this event or some event, the Extreme Enterprise event, we're going to work on that. Okay, so here's an event for Nigeria, or where we focus on those aspects. It will have to be localized to everything.
Okay. Next question is from Liane. The question is: have you looked at Habitat for Humanity as a compare and contrast?
Yeah. Habitat for Humanity is the best example. They're doing some impactful work and sheer volume of houses that are built. We'd love to collaborate with them if we can. So we'll see how we can do that.
Well, have you looked at them? Have you looked at them in terms of dealing with the localization question?
I volunteered at Habitat a few times back in college. I mean, I haven't.
But I mean,
particularly
has
that.
there been like board level contact? That seems like, you know, there's some common ground there, and they've solved a
Absolutely.
lot of the problems.
Yeah, we got to do it. If you can connect us to any other board level people, we'd love to see that. We haven't reached out like that yet. We weren't ready for it. Right now, this is probably the time to do it.
Well, I'd love to learn more about what you've done so far. I was just scouting about on your other site. So,
Yeah.
well, feel free to contact me. I have a charitable organization, and we have open mental space for doing something along these lines.
Okay. You're Leanne?
I'm Leanne Newton,
Leanne.
and
Okay.
I think I assume there's a way you can contact me from just my
How are we
having
doing?
logged in here.
Am I getting a list of the participants with their emails at the end, or?
Otherwise, you can find me on the FabX community site, or I'll text you. I'll send you my email.
Yeah.
In chat.
Yeah.
Directly.
And I'm Marcin at opensourceecology.org.
Yes.
Yep. Yeah.
Thanks, Leanne, for doing that. Next question is from Pete. Have you thought about regulation events such as inspections or permits that require serialization of activities?
Yeah, we're gonna have to make it work with that. So maybe the foundation gets done and inspected ahead of time. That this is all to be developed in a legal section, and there are restrictions to that. By all means, you might have to have certain parts inspected. But if we say you build this with a friend over 1 week, well, you might have to do half a week today and half a week a month from then after inspection. So that's still compatible with this kind of model. If we're doing a model where we had the 5-day window, like in our extreme builds, no, you cannot address the inspection model that well there. But with this model, you can, because you can phase things out, space things out.
Okay. So with that, all the questions ends. I do want to ask you, Marcin, one question.
Yeah.
And it's the software tooling, or rather the mechanism around this whole plan. As in I mean, it's most of the time spent on the supply chain and the transactions and the acquire and getting things acquired, especially in countries which are developing countries. They take a lot of time. So how do you sort of plan to build on the software stack to support your plans?
Software stack. Well, right now our software stack is very primitive. It's wikis, FreeCAD. I mean, wiki can be scalable. We don't have anything advanced, and I also think that not using anything advanced but simple, accessible tools, I don't see the limit of that to be able to handle the kind of population that we need. We're going to need a conference call that handles 2,000 people. We're going to need a wiki that handles 2,000 people, and we're going to need editable docs, which clearly with Google Docs you can have thousands of people. So, but once again, modular, like each thing is a separate entity. Like in the modular design, you have many different websites you go into. I don't think that's a main challenge. After we get good at what we're doing here, we can probably talk about a customized, specialized platform for this. But right now, this is so wild and agile that I think to do something like you're suggesting in terms of a specialized stack to handle this is excessive at this point. That's my opinion on a topic.
Okay. Thanks for that. I think the questions are finished now, and thank you for your wonderful presentation. I ask everyone if they want to leave any contact details, please post on the chat, or maybe they can contact you on your email ID that you posted.
Yeah.
Okay. With that, thank you, everyone.
Thank you. Thank you for being a good audience, and look forward to making this happen.